All right, here we go, continuing with 8-4. Now, one of the reasons I like to break these videos up into chunks like this, A, it's quicker for me to upload them usually. I have crappy internet where I live. And B, y'all don't want to watch me write all this stuff. So that's why I try to write it in between clips. Anyway, let vector B be given by components A1, B1. Vector W be given by components A2, B2, okay? And C be a real number. Vector addition means to add vector B, vector W, just add their components, okay? Vector subtraction, what do? V minus W, you subtract their components, starting with the A1, subtract A2, and so forth. All right, multiplication of a vector by a scalar. Let's suppose you have some number C multiplied by your vector. All you do is you multiply each one of the components by that number C, whatever it happens to be. All right, so we have an example next. Our example reads what? Perform the indicated operations. So we have some operations on vectors here we need to perform, okay? So, our example, we have vector W, which is given in component form by -3, 7, and we have vector S, which is given by components -1, -2, okay? And for part A, they want us to find vector W minus vector S minus vector S. All right, so how am I going to do that? I'm going to say, let's take the first component in vector W, subtract the first component in vector S, so subtract the -1, or I can say add 1. Take the second component in vector W, which is 7, and subtract the second component in vector S, which is -2. Then just do the math, okay? What do we have? -2, 9. So what is -2, 9? That's vector W minus vector S. How about part B? Part B here says, let's take -4 times vector W. So I have a scalar multiplied by a vector. How do I do this? Well, it's -4 times what's the component form of vector W? It's -3, 7. So we just distribute basically this -4 in here. So what does that give me? 12, -28. That's -4 times vector W. Let's see, next page. On the next page, they talk about a unit vector. They say a vector that has a magnitude of 1 is called a unit vector. What's magnitude again? The length, right? So why do we call it a unit vector? Because it's 1 unit long, right? Vector that is 1 unit long, basically. All right. Then your book says how to find a unit vector in the direction of the given vector. It says if vector B is given in component form by A, B, then a unit vector, which they call they call U subscript of V for the unit vector. They say in the direction of V is given by this. The way we find that, the unit vector is we say 1 over the magnitude of vector V times vector V, like this. So that should be easy enough. That's one way you write it. They have multiple ways to write this, okay? I think in your notes you have this. In your notes you have this, times vector V. But what is vector V in component form? Vector V in component form is just A, B, isn't it? So either one of these ways would work. All right, let's see. Next we have represent vectors in terms of I and J. All right, so let's talk about I and J real quick, okay? What are I and J besides letters in the alphabet? All right, let's suppose we have an x-axis and we have a y-axis. And I look at the point right here, 1 on the x-axis, and I look at the point 1 on the y-axis here, okay? Oops, almost lost my notes there. All right, so it says vector I is given by the vector with components 1, 0. So what they're saying right here is a vector that's in standard position and has a terminal point at 1, 0, we're going to call vector I, pick a different color here. And we're going to call vector J the vector that's in standard position that has its terminal point right there at 1 on the y-axis. So we're going to call that vector J. So now what are we saying? We're saying a vector I is a vector in standard position that is given in component form like this. And vector J is a vector that's given in component form like this. All right, now, what do they talk about here? They talk about any vector can be expressed as a linear combination of I and J. Any vector, we can represent it in terms of I and J. All right, so that brings us to our next example. It reads, find a unit vector in the same direction as vector V. Find a unit vector in the same direction as vector V. Let's see. Part A. We're given vector V in component form as -11, 60. And what do they want? They want a unit vector in the same direction. Well, I know if I want to find my unit vector, I'm going to do what? I could call it U subscript to V is equal to 1 over the magnitude of this original vector, 1 over the magnitude, times that vector. All right, well, let's go ahead and find the magnitude of vector V so I can plug it in this formula. So over here, I'm going to say, okay, let's find the magnitude of vector V. What is that? That's the length of it, right? How do I find the length of it? I use that distance formula. Well, normally I use the distance formula, right? But whenever it's in component form right here, what I do is I do this, -11 squared plus 60 squared. Because what you could think of is this is a vector V with components -11, 60. So that means -11, 60 way up here. I have a vector that's in standard position that goes to -11, 60, that point, okay? And you can think of, if I use the distance formula, whenever I subtract my x values, this is at 0, 0, right? I have -11 minus 0 squared, or -11 squared, and I have 60 minus 0 squared, okay? So that's why I don't need to bother with the minus the other x value. All right, anyway, let's continue with finding the magnitude here. All right, let's see. That's the square root of what? 121 plus, what is that, 3,600. All right, so what do you get when you add those up? You get 3, 7, what, 2, 1. And I don't think that comes out very nicely. Actually it does. Put this in your calculator, you get exactly 61. So what are we saying? The magnitude of vector V is 61, right? So if we come over here to our formula, we have 1 over the magnitude, which was 61, times the components in that original vector, which were -11, 60. Now what we have is just a scalar, which is 1 over 61 multiplied by vector, so we basically just distribute this in here. So that gives us -11 over 61, 60 over 61, and this is a vector in component form, so we're going to put that. So what is this? This right here, yeah, it's my answer, but it's a unit vector the same direction as that original vector. Remember earlier whenever I drew that original vector, it was like way over here? Well, now we just have a unit, so we have a vector that's 1 unit long in the same direction as that original vector. Let's look at B. B isn't beautiful. This stuff is beautiful, right? Some of y'all probably don't think so. It's all in the eye of the beholder, right? B. B, we're going to have vector V is equal to 6i minus 15 times vector j. Oh, why do they want to do this? Everything's going smooth. All right, remember what I and j were, okay? What was I? In component form, I was 1, 0, right? What was j? Actually, let me put the bar over it. The indicator's a vector. Vector j was given by the component 0, 1, right? Those were the unit vectors in standard position going along the x and the y axis. All right, so let's see. Let me clean this up, okay? Let me say, okay, this is 6 times vector I. So vector I is given by 1, 0, right? Minus 15 times vector j. Well, vector j is just given by what? 0, 1. Well, this is just a scalar times this, so now I have what? 6, 0 plus, and if I take negative 15 and multiply by this, I get 0, negative 15, right? I have two vectors that look like that. Now, how do we do vector addition? We add their first components, 6 plus 0 is 6, and add their second components. So we get 6, negative 15. So that's another way to represent vector v. In component form by 6, negative 15, okay? So that's really vector v. Now what do I want to do? I want to find the unit vector in the same direction as vector v. So if I look for this, the unit vector in the same direction as vector v, what I'm looking to do is use the formula 1 over the magnitude of vector v times the component form of vector v, right? Let's see. Need some more room here. All right, so let's calculate the magnitude of vector v. The magnitude of vector v. We said that that's given by the square root of first component squared plus the second component squared, right? So what is that? Square root of 36 plus what is that? 225. So if I add these, what do I get? I get a 1 at the end. I get what? 6 there. And then 261. Now, instead of boring y'all with the details of how to simplify this, I did this earlier. And I got 261 is the square root of 9 times 29. And the square root of 9 comes out as 3. And then 29 stays under the radical. So what is this number? That's the magnitude of vector v, right? So whenever I come back to this formula, I can say 1 over, instead of this symbol, I could write 3 square roots of 29 times the component form of my original vector, which was what? 6, negative 15. 6, negative 15. All right, well, let's keep going here. So if we keep going here, we get what? We basically distribute this in here, so we get 6 over 3 square roots of 29, 3 square roots of 29, comma, negative 15 over 3 square roots of 29. Now let's simplify each fraction, okay? Wouldn't that be the same thing as 2 over the square root of 29 and negative 5 over the square root of 29? Now let's rationalize each one of these. So that's 2 over square root of 29 times the square root of 29 over square root of 29. Negative 5 over square root of 29 times square root of 29 over square root of 29. So what does that give me? 2 square roots of 29 over 29. Over here I get negative 5 square roots of 29 over 29. Let me put these symbols right here for showing that it is a what? It's a vector. Okay. Now, my only thing is here, I want to go ahead and put it back in terms of I and j, because it was originally in terms of I and j, okay? So let me see, how am I going to go about putting it in terms of I and j? Well, really it's not hard at all. So what you do is you picture this thing, okay, being 2 square roots of 29 over 29 times I minus 5 square roots of 29 over 29 times j. Now why could I just add I and j on them like that, okay? Let's go back to this first part, what we had. Okay, we had I and j here, right? And we said that that was this before I had to erase. Okay? And then we said that gave me 0, negative 15. So what did I end up with? 6 and negative 15, right? 6 and negative 15, which is the same numbers I have multiplied by I and j respectively, right? So what if I started with this and went backwards? Where would I get to? I would get to the first component times I plus the second component times j, right? Isn't that what I did here? First component times I plus the second component times j? Sure did. So here is what? My unit vector in the same direction as that vector.